What is up, everybody? Welcome back to the Maths Guide. Today we're going to be covering the 25 most common questions that have been coming up in the Maths SATs for year 6. So if you're here today, it means you're pretty serious about getting the best mark you can in your upcoming SATs this summer. Now, what I advise you doing is using the link in the comment sections below, download the paper and take 25 minutes to try and see how many marks you can get on your own. Then come back to this video and check how well you did as we go through the paper and see how to solve these questions. So I'm going to assume that you've done your test. Let's get into question 1 and see if you got it right. So question 1 is a sequencing question. We can see it says, what are the next two numbers? And sequencing questions are very common in SATs. So we can see we have 26, 20, 14, 8, and then we're looking for two more numbers. So we can also see that our numbers are descending, which means they're going from larger to smallest. So the trick to answering a sequencing question is simply to find out what is the pattern between the numbers. So if we look at the number 26 to the number 20, pattern would be -6. We're taking off a 6. Between 20 and 14, we're also taking off a 6. And between 14 and 8, we are also taking off a 6. So therefore it makes sense that between 8 and the next number, we're also going to take off a 6. So 8 subtract 6 would leave us with 2. Now things get a bit more challenging because we're also going to have to take a 6 away from that 2. So 2 take away 6 leaves us in the negatives, and we end up with -4. Not too challenging. Let's get to question 2. Question 2 says 2 factors of 28 add up to 9. What are they? So first of all, what is a factor? Well, a factor is two numbers that multiply together to equal our given number, which in this case is 28. And we're looking for two of those factors to add up to 9. So we're going to start with a factor tree. And I'm going to put my 28 here, and then the first logical pair of two numbers that are going to multiply together to equal 28 would be 1 and 28. Then I'm going to try the next logical step of 2. I think I can times 2 by 14. Then I'm going to try 3. 3, 6, 9, 12, 15, 18, 21, 24, 27, 30. So 3 is not a factor of 28 because it didn't land directly on 28. Let's try 4. 4, 8, 12, 16, 20, 24, 28. So 4 works with 7. Let's try 5. 5, 10, 15, 20, 25, and then 30. So 5 doesn't work. What about 6? 6, 12, 18, 24, 30. So 6 doesn't work. And then we come all the way back round to 7. So if I had 7 here, this pair would be 4. And we already have that pair in the previous section. Because if we remember about multiplication, it's commutative. So 4 times 7 is the same as saying 7 times 4. So we don't need those there. So our factors of 28 are 1 and 28, 2 and 14, 4 and 7. And it says 2 of them need to add up to 9. Which 2 are they? Well, I think I can get my 7 and add it to my 2, and I'm going to get 9. So my answer would be 2 and 7. Not too challenging when we understand what a factor pair is. Now we have what looks like a hard question, but there is a really easy trick. Multiply 62 by 100. We can use our place value chart. So I'm going to set up a place value chart over here, put my ones, tens, hundreds, thousands, and I'm going to put my number 62 with 6 tens and 2 ones. Now what I have to understand is when I multiply, my number is going to get larger, so it's going to come up the place value chart. And if we're timesing by 100, there is a very nice little trick, because what we should know about place value charts is every jump is times 10. So between each of these columns, it gets 10 times larger. And the same coming backwards, we divide by 10 because you're getting 10 times smaller. So if we're multiplying by 100, we're going to need to go times 10 and then times 10 again. So it's going to be 2 jumps. So let's take our 6 and take 2 jumps. 1, 2, 6 lands in the 1,000 column, 2 lands in the 1, 2, 100 column, and then I'll fill the rest with placeholders. So my answer is 6,200. Simple. Use your place value chart. It's really important. What is 2/3 of 24? Well, this might sound a bit tricky because it's written in words. So let's rewrite it with 2/3 of 24. So what we've got here is a fractions of amounts. Our amount is 24 and our fraction is 2/3. So let's think logically. If we've got 2/3 of 24, then our answer has to be smaller than 24 because we've got a fraction of that amount. So how are we going to do this? Well, if I know I've got 24 and I'm looking for 2/3, then I think I'm going to be sharing them into thirds, which is like saying 3 circles. Share my 24, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. We have an even amount in each, so we know we've done that right. So in each sharing circle we have 8, but we're not looking for just one sharing circle because we're looking for 2/3. So I need 2 sharing circles. So if I have 8 in each, then I have 8 plus 8 equals 16. So 2/3 of 24 equals 16. Use your sharing circles if you want, or a quicker way, I could have just done 24 divided by 3 equals 8. 8 times 2 is 16. So there is the written method as well if you'd like to do that instead. Question 5. What is 1/2 added to 5/8? A fraction question again. So let's rewrite it. We have 1/2 added to 5/8. So what we need to understand about adding fractions is we cannot add fractions if our denominators are different. So I'm going to have to try and find an equivalent fraction of one of these fractions to make it so they have the same denominators. So let's look at 1/2 and let's try and convert it to having a denominator, the number at the bottom, of an 8, which is what our other one has. So let's put that in place, and then let's think about how we got from 2 to 8. Well, we times it by 4. So to keep this fraction equivalent, we're going to have to times the numerator by 4 as well. So 1 times 4 is 4. So now I can get rid of 1/2 because an equivalent fraction is 4/8. Now when I'm adding it, all I need to think about is the numerators. I'm going to add 4 plus 5 equals 9. And then because we've been working in eighths, I've got 4/8 plus 5/8. I'm going to end up with 9/8. Just like if I had 4 elephants, add 5 elephants, I would get 9 elephants. We're working in eighths, so that's what my unit's going to be. So I could finish here at 9/8, or I could realize that this is an improper fraction, and there is actually a whole group of 8 in my 9, so I could convert it to 1 whole and 1/8. Either would be fine. Next question, question 6 says divide 47.5 by 10. And again, it's trying to trick us by putting this into words, making it harder for us to understand. So let's write it. Divide 47.5 by 10. So again, what can I see? Well, I'm dividing by 10, therefore I can use my place value chart to help me, but this time I've got something in the decimals, so I'm going to have different titles. Let's put my ones here, tens, hundreds, put my decimal in place, tenths and 100ths. Now I'm going to put my number in place. I have 47.5, so I have 4 tens, 7 ones, point on the decimal line, and 5. And then if I'm dividing, well, this time I'm going to come down my place value chart. How many times am I going to come down? Well, we're only dividing by 10, so we're only going to move 1 place. Let's go then. So 5 comes into the hundredths column, 7 into the tenths column, put back the decimal in the right place, and then 4 into the ones column. So my answer is 4.75. Easy when you use the place value chart. Question 7 says round 19.3 to the nearest whole number. So what we have to understand is a whole number is a number without any decimals afterwards. So we're looking for just a whole number. So I need to understand which 2 options I have. I have a lower number and I have a higher number. Well, if it's 19.3 and I draw a number line, 19.3 will sit somewhere between the whole number of 19 and the whole number of 20. So my 2 options would either be 19 or 20. But which one? Well, as we're rounding to a whole number, we're going to be looking at the number in the fraction, the decimal, to help us understand if we round up or down. And we have a little rule, don't we? If it's 0, 1, 2, 3, or 4, we round down to the floor. If it's 5, 6, 7, 8, or 9, round up all the time. So because it's a 3, we can see it here, means we round down. which means we're going to be keeping our number at 19. So the answer would be 19. We could also see, by looking at this number line, if it's 19.3, we could probably put it reasonably accurately about there on my number line, and we can see that that's closer to 19 than it is 20. So I could draw a number line to help me as well. Question 8. Which of these numbers below are exactly divisible by 9? Okay, so I've got a bit of hard work ahead of me here. Let's start putting them into bus stop. Let's start with 119. So 119 divided by 9. How many 9s in 1? 0. Move the 1 across. How many 9s in 11? 1 with 2 remainder. How many 9s in 29? 9, 18, 27 is 3. Remainder 2. So 119 is not exactly divisible by 9 because we have a remainder. Okay, let's try 702. So I have 702 divided by 9. How many 9s in 7? 0. How many 9s in 70? 9, 18, 27, 36, 45, 54, 63 would be 7 with 7 remainder. How many 9s are there in 72? Well, there's exactly 8. So my answer would be 78 with no remainders. Therefore, 702 is exactly divisible by 9. Now, this is where some people can make a mistake. They might have found 1, but there might be more. So unfortunately, we're going to have to continue to see if there's any more in the rest of the numbers. 4, 3, 2 divided by 9. How many 9s in 4? 0. How many 9s in 43? 9, 18, 27, 36, 45. So it can't be that one. It's 36. So there's 4. Difference between 36 and 43 is 7. How many 9s are there in 72? Well, we already had that one before. It's 8 with no remainders. So we also know 432 is also divisible exactly by 9. Let's do 641 divided by 9. 9's into 6, don't go. 9's into 64. 9, 18, 27, 36, 45, 54, 63. That's 7. 1 left over. How many 9s into 11? Go 1 with 2 left over. Therefore, 641 is not divisible by 9. One last one, and then we can take a breather. 372 divided by 9. How many 9s in 3? Don't go. Move the 3 across. How many 9s in 37? 9, 18, 27, 36. So I have 4. 1 left over. How many 9s in 12? 1 with 3 left over. Not divisible by 9. So my only two answers are 702 and 432. Let's move on. Put these in order of size. Smallest first. So we have 0.4, 60%, and 1/5. So the important thing to do is get them into the same units. And because we have 0.4 at the start, let's get them all into decimals. So 60% as a decimal, well, if it's 60%, it's not quite 1. It'll be somewhere in our tenths column, and it's 0.6. 1/5, well, we're looking for 1/5 of 1, and we can say that 1/10 of 1 would be 0.1, but it's not 1/10, it's 1/5, so it's going to be double that, so it's 0.2. If you're looking for some more help on converting between units, then find that specific video on this channel. So now we have them in order, we can clearly see the smallest one is 0.2, but it asks us to put these in order. So my first answer is 1/5. Then the next one would be 0.4, which is already in 0.4. And then the last one, 60%. Pretty easy if we can understand how to convert between units. Which fraction is equal to 3/4? We have 4/7, 6/8, or 6/9. So we're looking for that equivalent fraction again. So let's put 3/4 here, and we're looking to see if we can make them equivalent with any of these three. So let's try 4/7 to start with. Well, I can't see a relationship to multiply my 4 to the 7 or to multiply my 3 to the 4. So I know that 4/7 is not going to be equivalent. Let's try 6/8. How do I get from 4 to 8? Well, I multiply by 2. How do I get from 3 to 6? I also multiply by 2. Therefore, 6/8 must be equivalent. Awesome. But let's check, make sure 6/9 isn't. Because remember, we might have more than one answer. So 6/8 ninth. How do I get from 3 to 6? Multiply by 2. But if I multiply 4 by 2, I only get to 8. So therefore, not equivalent. So the answer, 6/8. Okay, question 11. 14 plus something is the same as or equal 80 divided by 4. So it's important to understand what this equal sign means. It doesn't necessarily mean this equals this. It's basically saying everything on either side of this equal sign is balanced, is the same. So to work out this side here, we're going to need to work out the right-hand side. So 80 divided by 4 is 20. So what this question is saying is 14 plus something equals 20. Well, I can see that 14 plus 6 equals 20. But if I couldn't see that, I could do the inverse and do 20, subtract, because subtraction is the inverse of addition. 14 equals 6. And then put my 6 in place to answer my question. 14 plus 6 is the same as 80 divided by 4. Easy. Question 12. We have brackets. So with brackets, we need to understand the order of operations, or in other words, BODMAS. And BODMAS stands for brackets, order, divide, multiply, add, subtract. This is the order of operations. So we can see first we have brackets. So we need to solve these brackets first. So let's do 16 divided by 4. 16 divided by 4 is 4. So it's going to be 4 times, and then solve this bracket. 7 subtract 4 is 3. So now we can just solve 4 times 3 equals 12. So our answer is 12. Easy if we understand the order of operations. And remember, BODMAS is our friend to help us remember. Pretty straightforward one with question 13. What is 42 divided by 6? So I could use my bus stop. I could put my bus stop here. 42 divided by 6. But it doesn't really help me because how many 6s are there in 4? 0. So I end up with my 42. Anyway, so I'm just going to go open my multiplications. 6, 12, 18, 24, 30, 36, 42. My answer is 7. Question 14. What number is halfway between 13 and 31? So I have a few choices. I could draw a number line, 13 and 31, and then fill in all the numbers between it, 29, 30, and 31. So to find the number in the middle, I could just simply start with my 13 and my 31 and come in 1 and back 1. In 1, 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 back 1. And then I'm left with a number that has no friends, so that's going to be the number in the middle. So my number is 22. Now that method is okay if you've got lots of time and lots of space, but sometimes we might have a huge number. We might say, what's the number in between 1 and a million? Well, you definitely don't want to be drawing a number line for that, so we need another solution. So because we're looking for a number halfway between, what we want to do is find out what the full gap between them is, or the range between them. And we can do that by doing 31 subtract 13. And 31 subtract 13 is 18. But we're only looking for halfway between. So if I get my 18 and divide it by 2, I'll get 9. So this gap here between half of them is 9. So to find out what that number would be, I could either do 13 add 9 would get to 22, or I could do 31 minus 9 would also get to 22. So I'll do 13 plus 9 equals 22. Simple. Question 15 says the coordinates of a square are 7, 2, 7, 7, 2, 7, and something. So we're missing a coordinate. So coordinates mean we're going to have to draw a graph, even if it is pretty rough. You might have a ruler and be able to do this better. And I'm ready to start. So when we're plotting coordinates, so for example 7, 2, we need to understand which numbers these refer to. Well, this axis here is called our x-axis. And this axis here, the vertical one, is our y-axis. And the two numbers, the first number is on our x-axis, and the second number is on our y-axis. So when I'm plotting this, first number is 7. So on the x-axis, I'm going to come along to 7, which is just here. But then I'm going to go up 2, so I can see my coordinate is going to be just about there. Again, you could be a lot more accurate because you might have a ruler and things. Next is 7, 7. So again, x-axis first to 7, then y-axis also to 7. Second one is 2, 7. So this time I only come across to 2, but up to 7. And the last one we don't have. But we can see already the shape of this square means it's likely going to be somewhere in this area here. So the first thing I'm going to do is draw my square, which I've just done here in green. And I can see that this point lines up to the 2 on the x-axis, and also a bit inaccurate, sorry, but it should be the 2 on the y-axis. And we can check that, because if we see all of our coordinates, we should have pairs. So I have a pair of 7s, a pair of 2s, another pair of 7s, and another pair of 2s. But that's a bit of a cheeky way of doing it. Best thing to do, draw your graph. Okay, we have a calculation question. Calculate 10 minus 5.6. Sounds easy, but actually when we get to it, we're going to realize it's quite hard. So 10 minus 5.6. Now, some of you might be able to just use your heads and realize how to do this. If you can, use your mental maths, always use that first, but then check it with the written method just to be sure. So I'm going to go straight into the written method, and I'm going to write my 10 minus 5.6. Is that correct? No, because what I've done here is I put this decimal 6, the fraction, in the ones column, and I've put the 5 in the tens column. Well, that 5 is not a 10, the 5 is only a 1. So the 5 needs to go into the ones column, then I need a new column for my decimal point and my sixths. So then I need to fill the rest in by putting a decimal and a placeholder, and putting a placeholder over here as well. So my question actually says 10.0 subtract 0.5.6. Now I can start. Where am I going to start? Well, I'm going to start in the smallest value, which in this case is my tenths, and I'm going to do 0 subtract 6. Well, if I have 0 anything, I can't take 6 away. So I can't do that, so I'm going to have to look next door to see if there's anything I can borrow. But there's nothing in that column, it's a 0. So I'm going to have to get this 0 to look next door and see that that's now a 1 in the tens column, which we're going to take, put that down to a 0 in the tens column, and put a 1 in my ones column. So now in my ones column I have 10. Now I can start again and look in my tens column and do 0 subtract 6, but I still can't do it. But this time when I look next door at my 10, I can see that I have a whole 10 that I can borrow, taking that column down to a 9 and bring the 1 across. Now I can start again and say 10 subtract 6 is 4, put by my decimal, 9 subtract 5 is 4, and 0 subtract 0 is 0. So my answer to this pretty awkward little question is 4.4. Next question, question 17. What is 2/5 of 60? So we have that fractions of amount again. 2/5 of 60. So I'm not going to bother doing my sharing circles. I'm just going to use the written method. So 60 divided by my 5 is 12. But we're not just looking for 1/5 of 60. We're looking for 2/5 of 60. So I'm going to get my 12 times 2 equals 24. Pretty quick and pretty easy with the written method. Question 18. What is 30 multiplied by 200? So I have 30 multiplied by 200. Well, we could use our place value chart to work out what 30 times 100 is, and then just do it again and add them together. So let's use my place value chart over here. And if I've got ones, tens, hundreds, thousands, 10,000s maybe, let's put my 30 in place. And if I'm timesing by 100, it needs to come 1, 2. So my 3 goes in the thousands, 1, 2. My 0 goes in the hundreds, and I need 2 placeholders. So my answer is 3,000 to both of them. Then we just need to add them together. 3,000 plus 3,000 is 6,000. So sometimes we can use these little skills that we know to help us solve questions that might look unfamiliar. we can just manipulate them a little bit, change them so they're easier to do. Next question, question 19. What temperature is 15 degrees lower than 7 degrees Celsius? So basically what we're doing is we're drawing a temperature thermometer, and I'm at 7 degrees, and I'm coming 15 degrees lower. So if I'm coming 15 degrees lower, I'm going to be coming down my number line or down my thermometer, however you want to look at it. So I'm going to do this in stages to help me. And I'm saying that 7 degrees down to 0 degrees would be minus 7, but we're looking for minus 15. So I need to come another minus 8, which will land me on minus 8. So my answer, minus 8 degrees. Don't forget your unit, degrees Celsius. Question 20, one of my favorite kind of questions. 6 cakes cost £2.40. How much do 10 cakes cost? Well, if we want to find out how many any amount of them cost, we need to find out how much 1 cake costs. So if 6 cakes cost £2.40, and we want to find out how much 1 cake costs, we can just divide that by the 6. How many 6s in 2? 0. Put back my decimal, carry the 2 across. How many 6s in 24? 6, 12, 18, 24. And how many 6s in 0? 0. So each cake costs